I want to give you an overview of the flow, a workflow from the grid generation to the paneling part. And as you will see, and as we progress in the webinar, you'll see how there are different ways of generating your grid. And as I mentioned, from the top menu, there are all the different ways, and you can pretty much tell from the name. The array and array polar basically directly create your grids. Here you can use some base curves. So use one curve, two curve, and group of curves in one direction. The next one is a group of curves in two directions, and use their intersections to generate the grids. Here, if you have some points as input, maybe you can, with a reference surface, maybe you can organize them into a grid. The next section is all about creating the grids using surfaces as base geometry. And the last two actually are very useful when you have a poly surface. Now, we will explain that. But to start with, I will just generate an array of points, and as you see, I'm still inside my command. It's giving me a preview of what my grid is going to look like, and you will see a number of options on the top here, which includes the number of points in the U direction, which is where the red arrow is pointing. So if I change that to 10, for example, I'm going to see my preview changes to 10, change it to 12. Maybe the spacing, I want to change it to 2, increase the spacing in the U direction. Maybe the number in the V direction, I want to reduce it to 10. Possibly the direction in the V direction, I want to make it maybe in the Y direction, and if you wanted a parallel kind of grid. So as you see, you have all these options to kind of manipulate your grid of points, and it's giving you the preview to give you a sense of how it will look like. You can choose to group all the points, and you can attach a name for your grid. When you're happy with it, you just press enter, and this becomes your grid. It's now committed. And what you see, it's all grouped, but if you select one point, I've just selected the bottom corner point, and if you go to the Property tab, and I'm going to just drag it a little bit to show you a really important concept, particular to paneling tools, is that you'll see that each point in the grid is actually nothing but a regular Rhino point, except that it has the name of the grid, which is G in this case, with the row location and column location, U and V location of that particular point. Right? So for each point to be a player in the grid and to be understood as part of the grid, it needs to have that name. And this is why you can easily delete one of the points or change its location just by changing the tag or the name or its location right here as it shows. And that also gives it the flexibility to work well with the rest of Rhino commands, as well as you can generate it through scripting and other means. Once I have my grid, I'm going to group it again. Just so I think it's already grouped. The next step is that just because these grids are nothing but just a bunch of points in Rhino, and they will not change their names if you, for example, scale them. So let me just drag it a little bit here more. So if I scale my points, and then I go select that base point again, you see its name didn't change. So I can do all sorts of transformations, like bend, for example, I can choose to bend my points, as I mentioned, rotate them, scale them, project them to surfaces, any kind of function that will not change the name of each individual points, which is most of the Rhino commands, then you can use those. Once you are happy with the way your grid is looking, then the next step is to apply the panels or the paneling to it. And that comes from the second sub-menu in the paneling tools, which in this case I have just a flat grid, basically, one layer of points. They don't have to be planar, of course. So you can choose to select the first one, which is the first level of paneling. That will ask me to select my grid, and also will prompt me for a base surface. In this case, I don't have anyone, so I'll press Enter. And you'll see in a preview, it will show me how the pattern is looking, how these points are connecting, if you will. And if you look at the options, the top left option, you will see the pattern option. The paneling tools comes with a few built-in patterns just for your convenience, but you can expand that list really using the management. You can create your own connections basically and add any names to that list. So just from choosing from that list, you'll see how these built-in patterns are given for common kind of connections. Diamond connection, for example, let's say I want that for now, and I want my output to be edges. You can have your output to be edges or like an outline of the cell, which is a face border, or you add it as patches, as faces, and flat faces. You can choose to output a mesh, and again you can group your panels and give them some name. So you press Enter when you are happy, and again you see these arrows, the red one and the green one pointing to the U direction and the V direction of your grid. You press Enter, you have your panels created. Now they are groups. Let me ungroup them, and you'll see each one of these edges basically holds the name of your paneling group if you look at the property box on the right, and also a serial number to that edge. Sometimes this is useful for, once you get to a point where you actually try to manufacture and you want to label your parts. But you can relabel them to whatever you want, actually. But that's also for your reference.